Final review problem number 4. We're given the equation of motion for a spring mass system. Well, it could be a spring mass system, but it could also be all sorts of other phenomena in nature. It could be an oscillating atom. It could be the height of the ground shaking in an earthquake. It could be a piano string vibrating up and down. This is the equation of simple harmonic motion. It applies to all sorts of systems, not just springs. But we're given some values here, and I wrote down the particular values that I had when I opened up WebAssign. You'll have different numbers here. The point to keep in mind is that the generic form of this equation looks like this. So the amplitude is whatever this number is out in front. In my case, it's 0.21 meters. And the angular frequency is whatever is multiplying t. So in my case, it's 0.7 pi radians per second. Now there's one weird thing about how they write this in WebAssign. They didn't write in any units for you, because they say assume that t is in seconds. So really there's units associated with this number. It's omega, I should just write this down. Omega is 0.7 pi, which, wait, 0.7 pi is something like 2-ish. And it has units of radians per second, or 1 over seconds, because radians are a fake unit, like we've talked about. I'll put radians kind of in parentheses, radians per second. Okay, anyway, the next question is to find K, the spring constant, and remember that we have this other relationship for omega in the case of a spring mass system. Omega is square root of k over m. So if you flip that around with some algebra, you get k equals m omega squared. And the problem also tells you a value for m. I forget what it is. So you can just multiply m by omega squared. Yeah, and you got it. Now part C, this is purely plug and chug. All you do is take this time value, put it into this equation, and evaluate your result. Make sure your calculator is in radian mode, because again, this omega is radians per second. So when you do cosine of this stuff, your calculator needs to be in radian mode for you to get the right answer. Now what's the speed at 0.34 seconds? Well, we also learned this formula for speed, or velocity really, minus omega a sine omega t. If you've ever taken calculus, you might recognize that as the derivative of this equation. If you haven't taken calculus, don't worry. And just plug in all those appropriate values and you'll get the speed at that moment in time. So problem 4, we didn't have to do a whole lot of problem solving or crazy analysis or anything. I'm just making sure with this problem that you kind of know the basics of simple harmonic motion. You realize that this is the equation of motion, and you know what the definitions of those parameters in the equation represent.